So yesterday I did natural language processing by training a model from scratch. Tomorrow we are going to apply transfer learning to it and see how easier it has become because of it. So the code is same. I've organized it into this notebooks directory. Let me just zoom in a bit. So you go into this 2 underscore NLP directory, and in it you go into notebooks directory. And simple NLP is the same notebook as before. Okay. So the model we had before, we started with getting the data set, downloading the data set, and it's simple, converting it into the format we want. That's also simple, one line thing we use from scikit-learn. So in vectorize, we have already seen we map a word to a number. Okay. So these are the things: maximum vocab size and text, and we map it to a number. Then after we map that number inside, to that number, we embed meaning inside a vector alongside with it. So that's the dimensions we specify. Here we spent 64 bits. Okay. The code was like this: input layer, vectorize layer, then embedding layer, and then we do the classification. And if you check, this model is around 12 megabytes worth, pretty small. And if we train it, we immediately get accuracy of around 87%. This is what we did yesterday. Okay. Now moving on to transfer learning and how amazing it is. Just like in computer vision. In computer vision, we have arrived at standard base models, whether it is ResNet or it is EfficientNet, or there are a few common ones. Similarly, even in natural language processing, we have some such embeddings, and that's what we will check. So in one line, if you want to say, you just specify the embedding you want and you just download it. So in TensorFlow, we downloaded from TensorFlow Hub. PyTorch is going to have similar thing. It's just one line download of whatever embedding. It also has, Hugging Face also has such embeddings. Okay. So we download it, and in one shot, we have this one thing, that layer, we just have to give whatever the sentence we want. Its Google page tells us, how good this is. This universal sentence encoder, if you can find it here on Kaggle. So if you just open this link, it prompts you to this place. It reroutes you to this universal sentence encoder, and here it gives us those details. The details are like this: input is a variable length English text, and output is a vector of 512 dimensions. Okay, pretty cool. It is trained on variety of data sources and variety of tasks, with aim of accommodating natural variety of natural language. So it is the data which has been given to this is natural language processing data. That's also very good to know. It is optimized for good for sentences, phrases, or short paragraphs. So that's all it is. If you want to use it, one sentence, we have gotten the layer. We give whatever sentence we want to it. We get embedded sentence with it. This thing already contains the meaning. Here in model architecture, when we build embedding here, this is the place where the meaning of the word is gonna come. But it comes only after training. When we train the model, when the error is reduced, it's only then inside the embedding the meaning has been included. Whereas here, the meaning is already part of it. Google has spent a lot of time training these embeddings, and this is our starting point. So transfer learning, whether it is in computer vision or natural language processing, makes our job extremely easy. So this is what we do, and if you want to convert it into Keras layer for our TensorFlow model, it is just hub.keras layer, and same thing. Boom. No vectorization, no embedding, nothing. This already contains the meaning, and it is natural English language. Google has a lot of data, and from it has already extracted a lot of meaning. We don't have to reinvent the wheel. We can build on top of it. That's what transfer learning is all about. So we do that. Input layer, After that, I directly have the sentence encoder layer, which is hub.keras layer, and the path I have provided. Rest is a simple thing. We have one hidden layer of 64 neurons. Let me just say units equal to 64 here. This allows us to understand these units equal to number of neurons. So we have this, and when we train it, we will find that it trains in 2 minutes, 2 seconds. Compare it to the training we had above, it was 4 seconds. Not much difference, to be really honest. But the number of parameters have gotten drastically reduced. It the trainable parameters, because the sentence encoder we specify, what, I don't want you to be trainable because you already have the knowledge I need. In how much parameters, I have done summary here. So this is 1 GB worth of knowledge. Whatever knowledge, the best of it Google could find and build on top of it, it is already there. And on top of it, we are just giving, whatever parameters which are mentioned in remaining layers, and it gets trained very fast and gives us very good accuracy immediately. In first epoch itself, we got 77% accuracy. And by the end of it, we reach 83, and validation accuracy also increases. That is very rare. So in transfer learning, okay, we just simply say the thing. So instead of vectorize and then embed, we use ready-made embedding and build on top of it, and so simple. So any problem we want, we can build its pipeline like this. So this is amazing. So this is how you do transfer learning in NLP, and there are a few blocks which kind of like build a very great overview of the whole field. To expand my knowledge in this, I'm going to go through some of this, and I will continue this NLP thing with doing a milestone project in which medical papers are classified according to some natural language processing. So this is my goal for next week.